Welcome to another episode of Homeowners Electrical Professor. Welcome to all the homeowners and future electricians out there. My name is Paul Esposti. I'm your host. In this episode, we're going to start talking about some circuit breakers, okay? A little more detail. You basically have single pole, double pole, ground fault, arc fault, combination arc fault and ground fault, and then we have surge protective devices. Circuit breakers are there to protect the wire, okay, and with the case of ground fault, to protect humans. There's basically two reasons they trip: an overload or fault current. I have a video on basic faults, okay. Circuit breakers have two functions that cause them to trip. The two functions are called thermomagnetic type circuit breakers. The one thing that will cause them to trip is an overload. When the current flow exceeds the current value of the circuit breaker, there's a bimetal strip, it heats up, it slowly separates, and it opens the circuit breaker. The more the overload, the faster the trip time. This is referred to as inverse time function. Basically, an overload occurs when there are too many items plugged into the same branch circuit. A good example is in the morning when you have mothers and daughters all plugging in hair dryers at the same time. There's also what's known as the magnetic trip function, and that trip is used when there's a fault current. When fault current occurs, again, see those videos on faults, an extreme inrush of current occurs. There is an electromagnetic function that senses the extreme magnetism caused by that inrush of the AC current, trips the circuit breaker, and that is designed to occur in basically 1/30th of a second or less, okay? It's a very quick thing. Now, single pole circuit breakers. Basically, they will come in either a 15 amp or a 20 amp variety, okay? I went over this under wires and conductors, where basically your 15 amp breaker is going to be your convenience receptacles and your general lighting. The 20 amp is going to be more specialized for kitchens, bathrooms, laundry, and out in your garage they require a 20 amp receptacle. Okay, we also have double pole breakers. These are normally used for fixed appliances. Air conditioning units will be 240 volts, okay? Your single poles are 120 volts. You may have 15s, you may have 20s, you may have 25s, 30s, 40s, 50s. The larger items would probably be some type of electric wall ovens. If you have a gas oven, it's not going to require 240 volts, okay? The other thing I want to talk to you about is there are what are known as tandem breakers, where there are two breakers to fit on one spot, okay? If your panel starts to become crowded and you want to try to fit these in, there is one thing you have to be aware of, and that is that on a regular circuit breaker, if you see this space behind here, it's wide open. On a tandem circuit breaker, there's a tab here, and your panel will only accept a tandem circuit breaker if the bus bar stabs. I went over that on my main electrical panel. If the bus bar stabs have this notch, if this is flat across here, your panel is not designed to take the tandem circuit breaker, and it will not fit in there, okay? This panel is designed for them, so the circuit breaker will fit in there, okay? So be careful of that. If your circuit breaker is older and isn't made for that. The other thing you can look for is on your circuit breaker, this one here, on your electrical panel rather, this one here says it's 20 spaces and it'll accommodate 40 circuits, all right? If you go to the big box stores, what they mainly sell today is what's 100 amp, 20 spaces, 40 circuits. 150 amp will say 30 and 60, and a 200 amp panel will say 40 and 80. It's a lot of circuits to put in the house. Okay, so that is a little introductory to circuit breakers. Now there are also surge protective devices. Today's National Electrical Code requires them on new panels that are installed in residential units. There's really two types. One that mounts onto the side of the panel, and then these wires are connected, the white and the green are connected to your neutral bar, and then the two black wires would be connected to a 2-pole circuit breaker that's mounted in the panel. There's also one you can buy where it's all enclosed in the circuit breaker. This part here does not exist, and it would merely plug onto the electrical panel. The manufacturers of the surge protectors, they want it as close to the main breaker as you can get it. Okay, I'd also like to talk a little bit about the buttons on your receptacles that are either ground fault, arc fault, or a combination of arc fault and ground fault. The different manufacturers have a color code. As you can see, there's a little test button on this ground fault circuit breaker. This here is a square D. That's what my house has, so that's why I choose square D. Other manufacturers have a different color code, ITE, General Electric, Eaton, those brands. But anyway, if you have a square D panel and you see a little yellow test button on here, that means it's a ground fault receptacle. If this button were to be white, it would be an arc fault. If it's purple, it's a combination. It protects against arc faults and ground faults. I have a set of videos on what a ground fault is. You can look that up. I also have a video on what an arc fault is. Remember, a ground fault protects people and animals against getting shocked, whereas an arc fault protects, helps prevent fires.